Okay, guys, so I'm going through the review that we gave in class just so you can make sure that you're doing it right. Number one, sketch the graph and give the domain, range, amplitude, and list the transformations. Okay, so with this graph, y'all, I am going to go to my graphing calculator and I'm just going to check it out. Now, before I study the graph, I should be able to list the transformations though, because we should know what every part of this does, because this is just like the log graphs that we were doing. A negative in the front is going to be a reflection, like flip over x-axis. The 2 that you see right here, okay, a 2 in the front as a multiplier is a vertical stretch. So this is all just using my orange sheet and that layout. When something's inside the parentheses, it's left or right. So in this case, right 2, and then a number on the outside is the up or down, so up 1. So I know that this is what's happening to my graph. The other thing to note is that this is super important, because whatever is here, guys, and this movement also moves your asymptote. So I know that my asymptote is going to be x equals 2. And that's important because it goes right 2, so that when I graph it, I know to draw that myself. Okay, so I go to 2 and I draw a vertical asymptote. Okay, now the graphs of these usually kind of look like this, right? But we just wrote that it's going to flip, stretch, move right 2, and up 1. And so it's kind of going to have this shape, but I don't know exactly where it lies. So that's why I'm currently in my in a blah, blah, blah calculator typing it in. X minus 2. And then plus 1. Okay, so when I look at it, my graphing calculator does this, and it shows me that it crosses somewhere here between like 3 and 4, and it makes it look like the graph stops, but I need y'all to know that no, it does not stop. I need you to know that it is continues to go in this direction, okay? It always rides alongside the asymptote. And if you want a couple of good points, just go to your table. Like 3, 1 is on my table as a good point. Another good point, let me scroll down. It may be, well, there's not a lot of good points. So there we go. I got one good point out of that. And that's really fine by me. Okay, so there's number 1. All right, number 2 says, oh wait, I didn't do domain and range. Okay, so the domain, since this thing starts at 2, the domain is going to go from 2 to infinity. And the range, since there's arrows here and here, is actually all real numbers. So I'll write them just like that. All right, now number 2. Okay, number 2. Let me erase. All right. So on these we're going to be solving, and I gave you like 3 different styles of solving, but they all typically work the same. And on every one of these problems, guys, or almost every one, you know, there's a point in the problem where you might get stuck, and that's where you're going to want to rearrange. So I already know, that at some point I'm probably going to need to remember my ABC and how that moves to log base A of C equals B. We also wrote a version of this with natural logs where we wrote E to the B equals C, which is the same thing as log base E, which y'all, log base E is just natural log. Natural log base E of C equals B. So they kind of work the same. All right, now let's do number A. Or I guess that would be letter A. All right, 3 minus 2e 3 blah 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 equals negative 12. Okay, so if this is my problem, the first thing you always want to do is isolate your base, whatever the base is, right? So I'm going to try to get e by itself. So I'm going to start by adding 3 to both sides. Negative 2e. Okay, so a negative 12 plus 3 is actually a negative 9, correct? Okay, then we're going to divide both sides by negative 2. And then, and only then, are we ready to go. Okay, so e to the 3x plus 1 equals 4.5. And when I say ready to go, I mean we are stuck and we are ready to use these thingies up here. So right now, since it's a base, an exponent, and what it equals, it's just like this. E to the b equals c. And so I'm going to turn it into the other form in hopes that it helps me. So this is the e, this is the b, this is the c, and that's where they're all going to move. So natural log base e of 4.5 is equal to 3x plus 1. So in the calculator, we're going to type that in. When you hit natural log, when you're on your screen and you actually hit natural log, the calculator understands it's a base e. So you don't have to type that part in. And mine's giving me 1.504 blah blah blah. In fact, if I round it, it looks like this. Okay, and then I'm going to keep going, right? So I need to solve for x. So we're going to subtract 1. After we subtract this 1, we will divide off the 3. Divide by 3. And that's going to give me my final answer right here. So 0.5041 divided by 3, and that'll equal x. So minus 1 divided by 3. I'm just typing all this in the calculator. So x equals 0.168. That would be a good final answer for letter A. Okay, let's go back and look at B now, letter B. Okay, letter B says the natural log of 6x, I think that says minus 1, equals the natural log of 4x. Okay, nobody in class better miss this ever. Ever, because if these match, right, if you have a natural log in the front of both and they match, you can ignore them. They already match. So don't worry about those. Worry about what's behind them and making sure that they equal one another. This is Algebra 1 stuff, guys. So we need to solve for x. Minus 4x minus 4x. 2x minus 1 equals 0. 2x equals 1. X equals 1/2. Okay, old school algebra. I didn't really talk through it because you should know how to solve a basic equation, basic 1 or 2 step equation. All right, now we go to letter C. I'm going to erase this to make some room. Okay, letter C. I'm trying to see what was on that paper. Okay, so letter C, if I'm copying this right, here, let me scroll this down. There it is. Okay, it's 2 plus 4 natural log 6x plus 1 equals 5. Okay, so same thing. We want to isolate the base. And I know this isn't exponential, but in a way it kind of is because natural logs and exponents are very closely related, right? So isolate the log just as if it was an exponential. So isolate the base. So I need to get this by itself. So I'm going to start by subtracting the 2. And then after I subtract the 2, that would be what, 3. Okay, now it's still not isolated because that 4 is in the way. So let's divide both sides by 4. All right, and that's just 3/4. All right, so from here, this is the point where a lot of people get stuck. And once again, if you feel stuck, it's your cue to rearrange. And if you're thinking, well, how do I rearrange? Well, this is an invisible base E. As soon as you write that base E yourself, I'm going to scroll up because we have it right up here. Natural log, there it is. Natural log base E C equals B. I'm going to take this now, kids, and write it that way instead. So when I follow that whole what's the C, what's the B, and try to figure that out, it turns into E to the 3/4 equals 6x plus 1. And you can just type this in the calculator. Like, there's an E button, right? It's blue. Find the E button, take it to the 3/4 power. I'm getting, when I do that, you get something like 2.117, 2.117, then a bunch of zeros, and that equals this. Minus 1, and then after that, we will divide by 6. And then after we divide by 6, I'll divide by 6, divide by 6. I'm getting x equals 0.1862 after you round. So that's what I'm getting. All right, coolio. So the last one is, how much would you have to invest? What? how much would you have if you invest $23,000 for 10 years at 6.9% interest compounded continuously? Okay, so we learned a new formula. Hopefully you've put it on your orange sheet, and if not, put it on your orange sheet, and it's APERT. Okay, so this formula, A equals PE to the RT power. Just like the old stuff. P is your initial amount, your investment, so 23,000 will go there. E is our number E, so it stays in E. 10 years, that would be time. 6.9%, okay, so 6.9% would be my rate. Remember to turn that to a decimal, right? Which means move the decimal twice on a percent. And then 10 years would go here. All right, same thing. I'm going to type this in all at the same time using that E button. If you don't know where the E button is, we've been doing it in class, and you should have been practicing, so you need to come see me, because I will not be helping you on test day to find that button. 0.46. Okay, now why did I round it to 0.46 instead of 0.5 or 0.457? Because it's money, y'all. Money has dollars and cents, so I'm going to round it like that. Okay, great. Woohoo! Now, the follow-up question, how long before this 23K triples? Ooh, I'm trying to triple 23,000. Well, what does that mean? It means I want my 23,000 to turn into 69,000. How did I get that? The calculator. Okay, I didn't do anything fancy. It was just the calculator. And since it says how long will it take, instead of plugging in a 10 right here like I did above, this is my T. I don't know what it is. It's my time that I don't know. So now I'm going to try to solve this. And some of you might just want to go at this point. If you want to type this into y equals, you can, and that could be your x. And then you can go to your table. That would be one way to do it. Go to your table and search for that. If you want to solve it legit, then you'll start by dividing both sides by the 23,000. Which means you will get the 3 over here. All right, and now, just like this equation, like over here, or earlier we had it, we are stuck. Like, I don't know how to get the t out of the exponent. So we have an e, we have our exponent, and we have what it equals. So this is like the a, the b, and the c. So we're going to rearrange. So this is going to be log base e, which is ln base e, of 3 equals 0.069t. So I'm just going to type in natural log 3, and then I'm going to divide it by 0.069. So natural log of 3 divided by 0.069. Oops, I typed that in wrong. Oops, I did it again wrong. Okay. Okay, now I'm getting it. Okay, so I'm getting that time is 15.9 years. Okay, and I think that's all she wrote, kids, so hopefully that helped, and if not, come and see me. You have other homeworks that you could be working on for practice, and if you run out of those and want more practice, just come see me, and I'll help you out. All right, peace.